everyone, a very warm welcome to Diksha Karnataka YouTube channel. I'm Aditi, your physics teacher, and today we'll be seeing all the MCQs, all expected MCQs in your PU2 examination. These are very important from all the high weightage topics, all the important topics. I'll be giving you almost around 100 MCQs in this video. So let's get started. It'll be quick, since this is MCQs, so don't skip this video, be there till the end, watch all the MCQs and be ready to score full marks in your PU2 physics exam. Okay, let's start with our very first MCQs from the chapter electric charges and fields. Now according to the blueprint, the expected question is 1 from this chapter, that is MCQs, and HOTS is almost 0. So the first question says, when a glass rod is rubbed with silk cloth, what will happen? Either what? Silk cloth will lose electrons to glass rod, or glass rod acquires negative charge, that means it's gaining electrons. Third, glass rod will lose electrons to the silk cloth acquires positive charge. So for this, the correct option is glass rod will lose electrons, since in glass rods the electrons are not tightly bound. So it will lose electrons easily to the silk cloth, correct? Next MCQs, it says, the following figure shows the electric field around two charges, where now we have to tell if Q1 or Q2 is positive or negative, looking at the electric field. Now first thing you should notice are the arrows. So in all the cases, the arrows are pointing outwards. That means the electric field is going outwards in both the cases, and we know electric field is outwards only for the positive charge in such kind of cases. If it would have been something like this, that it's going in here and it's going out from this charge and something like this, then it will be of different charges, correct? But here the electric field are going outwards in for both the charges, that means both charges are positive. Hence, Q1 is positive, Q2 is negative, no. Q1 is negative, no. Both charges are positive. So the correct option is both charges are positive. Very simple. Okay, we'll be doing it very quick because these are quite simple, but these are very important still. These are all from the question bank given by the Karnataka board. Okay. The electrostatic force between the two charges in vacuum is given by this. We know that force is given by K Q1 Q2 divided by R square, correct? Now they are asking where K is. What is K here? So K I know, basically the value of K I know is it's 10 raised to power 9 into 10 raised to power 9. So this one cancels out, correct? This is minus 9, so this one cancels out. All these have different units. If we want to calculate, for force it's Newton, this is K. For Q1, Q2 it will be Coulomb square, correct? And for R square it will be meter square, correct? So if we find out, the dimensions will be Newton, meter square, Coulomb minus 2. And it is, obviously we know it is 9 into 10 raised to power 9, correct? So here the option which matches our value is what? Newton, meter square, Coulomb minus 2. This one, correct? So the correct option is A. Very simple. You got it how to do it. We just figured it out from the formula that was already given. Okay. Fourth question says, the direction of electric field vector at a point, on the equatorial line of a dipole. So if this is my dipole, and I know dipole moment is from positive to negative, correct? Dipole moment is from positive to negative. So electric field vector is always in the opposite direction. That is it. So it will be in the opposite direction of the dipole moment, correct? Electric field is always in the opposite direction of the dipole moment. Understood? Okay. Next question. When a free electric dipole, when a free electric dipole is placed in non-uniform electric field. Remember, it's a non-uniform electric field. The dipole will experience what? Both force and torque. Only force but not torque. only torque but not force, neither torque not force. Now, the thing you have to pay attention here is either it's uniform or non-uniform electric field, correct? If it's a uniform electric field, okay, if it's a uniform electric field, then the charge, the dipole will only experience torque, correct? There are questions, a question has also been asked where they just asked that the electric field is uniform. So, don't get confused. For uniform electric field, the dipole will only experience torque. But if it is a non-uniform electric field, it will also experience force along with torque, correct? So, in here the correct answer will be both force and torque for non-uniform electric field. For uniform electric field, the dipole will only and only experience, for uniform the dipole will only experience torque, correct? We are done with 5 questions. Okay, next. Dash placed in an electric field experiences a force in the direction of the electric field. Read the questions very carefully. If they have said in the direction, opposite to the direction. So, here a particle, let us say, is placed in the electric field and they are asking which particle will experience a force in the direction of electric field. So, I know that is very basic. The positive charge will feel the force in the direction of electric field. The negative one will feel the force opposite to the direction of electric field, correct? Now, in here electron is negative, this is also negative, both A and B is also wrong. So, the only positive charge present here is proton. So, proton will experience force in the direction of electric field, understood? Okay. 7th question says the physical quantity with SI unit coulomb per meter is. Coulomb per meter is very simple. Coulomb per meter is this. So, this is charge, correct, and this is, let us say, length. And what is charge by length? This is, ma'am, this is very easy. This is just linear charge density, correct? Very simple, yet very simple, yet very important. So, this is linear charge density, correct? 8th question says, name the physical quantity which has the dimensional formula of LTA, which is LTA. Now, let us just decipher what exactly is this. So, this is the unit of time, correct, and this is what? Ampere. Now, does that ring a bell? Ampere into time, which is Q. So, Q was what? I into T, QIT. I is for ampere, T is for time. So, this basically is L into Q, correct. Now, L is what? L is length, correct, and Q is charge. So, this is what? If you again use a little bit of just the brain, this will be 2A. Can I write? This is still length and this is Q. So, will that give me dipole moment, correct? Will that give me dipole moment? Dipole moment is what? P equals to 2Q into A, where 2A is the distance between two charges and Q is the charge, correct, magnitude of the charge. So, this gives me dipole moment, correct, understood? Okay. Next question, we are on the next chapter, which is electrostatic potential and capacitance. Now, this chapter you can expect 1 to 2 MCQs and HOTS, 1 out of 3 question can be HOTS from this chapter, okay. So, we will see both. Now, so the first question from this chapter is equal charges are given to the 2 spheres of different radii. There are 2 spheres of different radii, correct. They are asking the potential will be more on the bigger sphere, be more on the smaller sphere, be equal on both spheres, or depend on the nature of the materials. So, how will you calculate this? Ma'am, by writing the formula. So, V is just KQ divided by R. So, V is inversely proportional to the radius, correct? V is inversely, potential is inversely proportional to the radius. So, hence it will be bigger for the smaller one. So, the potential will be more for smaller sphere, correct? Okay. Next question says, the electric potential at the surface of a charged spherical shell. We have a charged spherical shell. This is my charged spherical shell of radius 10 centimeter. Radius is 10 centimeter and the potential is given as 20 volt. The electric potential at the center of the shell. What will be the electric potential at the center of the shell? Now, let me just write V is what? We saw KQ by R. Now, inside the charged spherical shell, potential remains constant. Potential remains constant. Understood? It's a uniformly charged sphere shell. The potential will remain constant. And here, if nothing is said, we'll consider that it is a uniformly charged sphere. So, we'll say the potential is constant as it is on its surface, and as the surface has 20 volt. So, inside at the center in the spherical shell, the potential will also be 20 volt. Understood? Okay? Okay. Next question, 11th one. The dimension of electric polarization is given by. So, what is electrical polarization? Electrical polarization is nothing but dipole moment divided by volume. Correct? So, dipole moment, how will we write? Dipole is LAT. Correct? Length into charge, just like we saw 2QA. 2A is my length, QT, Q is I into T. I will be T, I will be ampere, T will be time. So, for this the dimensions will be LAT, correct. Now, per unit volume, that means L cube, and if we solve this, we will get L power minus 1 A into T. Do we have this option here? We do have, sorry, this is minus 2, yeah. So, we do have this option, that is option A. That is very easy yet very important. Understood everything? Correct? Can we move? Okay. If you have any doubt, you can let me know in the comment section. I will definitely look into it. If you want me to cover any topic so that you can understand that, if you want to cover any particular questions, you can let me know in the comment section. Okay? Okay. Next question. The electric field at a point which is very close to the surface of a charged conductor. Electric field at a point which is very close to the surface of a charged conductor with surface charge density sigma. This is basically a clear-cut definition. The electric field in the form of charge density, surface charge density will be simply sigma by epsilon naught due to a charged conductor. Correct? So, it will be sigma by epsilon naught simply plainly. Correct? Okay. 13th question. This is a really great question. The following graphs show the variation of two physical quantities with a distance r from the center of a uniformly charged spherical shell. What? Uniformly charged spherical shell. Identify the graphs. Okay. So, it's basically E or it's basically V looking at the options. So, I know E varies inversely to the square of distance and V varies inversely to the simple for 1 power of r. So, this is what? Now, inside we know electric field is 0, but potential is not 0. So, this will be potential, this will be E. First graph shows variation of E, second is V, that will be wrong. First graph shows variation of V and second is variation of E. If inside, if uniformly charged spherical shell, all the charge resides on the surface, then the inside the electric field will be 0. From the surface and outside points, it will decrease with variation as 1 by r square, and this will change as variation with 1 by r. So, this will be my potential, this will be my electric field. Correct? So, B will be the correct option. Any doubt? If you have any doubt, let me know in the comment section. Okay? 14th, an electric dipole is placed inside an insulating spherical shell. Pick the wrong statement. Now, it's an insulated spherical shell. This is my spherical shell, but it's insulated. It is insulated now. Okay? So, we have to pick the wrong statement. So, it says net charge enclosed by the shell is 0. So, an electric dipole, there is an electric dipole placed in this. So, if my electric dipole is placed in a spherical shell, the total charge will be what? Plus q minus q, it will be 0. So, net charge will be 0. So, this statement is true. Then sphere acts as a equipotential surface. Okay, let's see. The C point is electric flux through the sphere is 0. Now, if inside the charge is 0, electric flux will also be 0. Basic. Okay, this is also true. Electric field is not uniform across the surface of the spherical shell. Now, see, they are saying electric field is not uniform, but inside this the charges is 0. According to Gauss law, we know E dot ds equals to q by epsilon naught, q enclosed by epsilon naught, but q enclosed is 0. So, this is 0. So, electric field is not uniform. It is wrong, right? Because electric field here is, here what? Electric field is 0, which is obviously uniform. So, this is wrong, and since electric field is 0, it will be a equipotential surface, and hence this is also true. Sphere acts as an equipotential surface. Understood? Any doubt, let me know in the comment section. Okay? Okay. 15th. Statement 1 says, the electric field inside a conductor is 0. Okay? Mostly true. All the charges reside only on the surface of the conductor. So, of course, both these statements are correct. We know that all the charges does reside on the surface of the conductor, and hence electric field inside the conductor is definitely 0. So, both are true and is the correct explanation of first. Correct? 16th says, the electric potential produced by a point charge and an electric dipole at a large distance r from them vary with Rs. So, we have to tell how the electric potential due to a point charge and how electric potential due to a dipole varies with R. Now, let us just see, for a point charge, ma'am, I know that it varies with 1 by R, correct? I have seen this multiple times. It varies with 1 by R, correct? That is correct. So, if you look at the options, what we choose is, we try to eliminate the wrong options. So, 1 by R square is wrong, 1 by R cube is wrong, 1 by R, okay, can be correct. This is also wrong. So, the B option is plainly correct. You do not even have to check for dipole moment. But, if you have to check for dipole moment, it will be inversely proportional to the square of the distance from the dipole. Correct? Okay. 17th question says, oh, we are on the 3rd chapter already. It says the chapter is current electricity, very important chapter. You can expect 1 question, and in HOTS you can expect 2 out of 3 HOTS question as well, like plainly compared to that. Okay. Now, 17th question says, when no current is passed through a conductor, what? When no current is passed, there is a conductor, but no current has been passing through it. So, what will happen? The free electrons do not move, or the average speed of a free electron over a large period of time is not 0. It's not 0. The average velocity of the free electron over a large period of time is 0. So, either this is correct or this is correct. The average of the velocities of all the free electrons at any instant is non-zero. This is non-zero. So, since there is no current in my conductor, there is no force on the free electrons. So, they are moving randomly, they are colliding randomly with the container, with each other, with free electrons, with ions. Okay. So, the average velocity of a free electron over a large period of time will be 0, not at any instant. At any instant, there might be some average velocity, but over a large period of time, the velocity, average velocity will be 0. So, correct option is option C. Okay. Okay. Let's move on to the next question, that is 18th. The relaxation time in conductors, what it increases with increase in temperature. It does not depend on temperature. It decreases with increase in temperature, and all of a sudden changes at 400 Kelvin. So, what usually happens is, if this is my conductor, correct, and there are electrons moving inside the conductor, there are lots of electrons and ions, metal ions, cations, okay. So, what happens is these electrons move and they collide with other electrons or ions. Now, relaxation time is the difference between the two collisions, okay, the difference in time between the two collisions. So, if I increase the temperature, they will move fast, the velocity of electron will increase, and if the velocity of electron will increase, it will collide with other electrons in less time, very fastly, correct. So, its relaxation time will what? Its relaxation time will decrease. Also, always remember, relaxation time is inversely proportional to the temperature. So, if temperature increases, relaxation time decreases. Relaxation time in conductors decreases with increase in temperature. So, C will be my correct answer. Okay, that is your 18th MCQ. 19th one says, n identical cells, each of EMF E. There are n cells, each of EMF E with internal resistances R connected in series. They are connected in series, a very important point. And external resistance R is connected in series. Now, another external resistance R is also connected in series. With this combination, the current through R is, we just need to find the current. So, let us draw, if this is, let us say, n number of cells, and they are each have EMF E and each has an internal resistance R. Now, they are connected with an external resistance R, correct. So, we need to find the time. So, time will be what? V by R, correct. This much we know. This will be all the sum of all the EMFs, that will be N into E, correct. And under with this should be, we should have total resistance of the circuit, which will be N number of internal resistances. So, N number of internal resistances plus a total resistance, that is R. So, this will be our final answer, that will be what? This one, okay. So, C will be the, no, not C, C will, where is the correct answer? That will be, which one? This one, correct. A will be the correct answer. There are n number of cells, each has n number of internal resistances and one single R external resistance. So, NE divided by R plus NR, correct? Okay. Next question says, oh, we have lots of questions, but all are literally same. A mobile charge carriers in case of metallic conductors are what? In case of metallic conductors, they will be what? They will be electrons, correct? Then the mobile charge carriers in case of electrolytic solutions are, in case of solution, they will be positive and negative ions, correct? Then the mobile charge carriers in case of ionized gas, for ionized gas, they will be electrons and, they will be electrons and positive ions, I guess. Sorry, yes, the electrons and positive ions, correct? They will be in ionized gas, there will be electrons and positive ions, because how the gas is ionized? We take electrons out of the those small atoms, okay. So, they become positive ions and the electrons are separated. So, that is how, so these are the charge carriers in case of ionized gas. Okay, 21st question already. Very good question. If the equation AB equals to C, A is current density, we have AB equals to C, where A is current density, that means it is J, and C is the electric field. So, C is electric field. Then B is what? Resistivity, conductivity, resistance, potential difference. Let us see. Now, if I remember, what is the relationship between current density and electric field? Ma'am, if you remember, it will be alternating form of Ohm's law, that is J equals to sigma E. Now, in this case, we have, here we have J into B equals to E, correct? So, if I write it in this form, this will be E divided by B, correct? So from here sigma is equal to 1 by b. If I compare these two equations, so sigma will be 1 by b, and sigma is what? Sigma is conductivity. Sigma is conductivity, and if B is 1 by sigma, so B will be what? B will be resistivity, correct. B will be resistivity, that is my option A. Understood? Everything clear? Do you have any doubt? In the comment section, okay? Along with the question number mentioned in the comment section, I will definitely reply you in the next video. Okay, 22nd question says, when a wire is not connected to a battery, then no current flows. Okay, makes sense. Current flows due to the electric field, and electric field is generated with the help of a battery. If there is no battery, there is no current. Then statement 2 says, in the absence of electric field, free electron moves randomly or does not move in particular direction. Is that true? That is true, because electric field gives a particular direction to your charges. They move, electrons move in the opposite direction of the electric field, and hence both the points are true. So both statements are true, and it is a correct explanation of statement 1. Okay? Okay. 23rd question says, a wire has a non-uniform cross-sectional area as shown in the figure. A steady current flows through it. Which one of the following statement is correct? Now, how do you approach this question? They are saying that current is flowing, correct? Current is flowing. Now, for flow of current, I know that I equals to NEA VD, correct? Where VD is drift velocity, I by NEA. Now, what are they asking? Which of the following statement is correct? The drift velocity of electron is constant. So, this is definitely depending on the cross section of the wire, and the cross section of the wire is different. So, it is definitely not constant. The drift speed of the electron increases while moving from A to B. Now, VD is what? Inversely proportional to A. Let us see what happens. So, at A part, the cross section area is less. So, VD will be more. Here the cross sectional area is more. So, VD will be less. So, it is decreasing. It is decreasing as it is going from A to B, correct? So, the drift velocity of electron increases. So, this is wrong. This is wrong. The drift speed of the electron decreases while moving from A to B. This is the correct answer that we just find out here. The drift randomly. No, it does not vary randomly. Okay, understood till now? 24th question says, which of the following is different from others? Which of these is which of the following is different from others? So, let us say volt square per ohm. So, this is what? This is V square divided by R, which is what? Power, correct? And ampere square ohm, this is I square by R, which is also power. Then VI, voltage into current, this is also power. But joule per second, which is work done per unit, what? Time square, this is definitely not power. So, this is the odd one out, correct? This is the different one. 25th question. Okay, we are on the 4th chapter, that is moving charges and magnetism. You can expect one question from this, and of course HOTS are again 2 out of 3. So, you can also expect good number of HOTS question from this chapter as well. Okay, let us see 25th question. The radius of the circle described by a charged particle moving perpendicular to a uniform magnetic field. Now, uniform magnetic field and radius, some kind of relationship? Yes, ma'am. This was mv square by r, and this was qvb, correct? So, this was, so okay, we can write r. So, r was mv divided by qb, correct? So, this is depending on what? Its mass, its velocity, its charge and its magnetic field strength. its mass? No, not on mass only. Both mass and velocity correct. Its velocity only? No. Neither mass nor velocity? No. So, it is depending on both mass and velocity. Correct? Understood? Very easy. Okay. 26th question says, an electron is projected with uniform velocity along the axis of a current carrying solenoid. This is my current carrying solenoid, and the electron is projected with uniform velocity along the axis. So, inside the field is uniform and there is an electron which is projected in the direction of along the axis of a current carrying solenoid. Which of the following is true? What did I do? Which of the following is true? The electron will be accelerated along the axis, or the electron path will be circular along the axis. The electron will experience a force at 45 degrees to the axis and hence execute a helical path, or the electron will continue to move with uniform velocity along the axis of the solenoid. Since, very important point, since the magnetic field inside the solenoid is uniform and it is not changing either the direction or the magnitude, until the magnitude is not changed, it will continue to move with uniform velocity along the axis of the solenoid. So, correct option is what? It's D. Correct? Okay, so the 27th, the next question says, a conducting circular loop of radius r carries a constant current I. Correct? If it is placed in a uniform magnetic field B such that B is perpendicular to the plane of the loop. Now, what we have is a conducting circular loop. Correct? We have a conducting circular loop. Okay, of radius r carries a constant current. Let's say it carries a constant current in this direction. We are just assuming it because it's not given in here what is the direction. Okay, it is placed in a uniform magnetic field such that B is perpendicular to the plane of the loop. Now, can I let this as the plane of the loop? Correct, this is somewhere the plane of the loop and B is perpendicular to the plane of the loop. So, this is B, correct? This B is perpendicular to this plane of the loop. The magnetic force acting on the loop, the whole loop we have to tell what is the magnetic force acting on this loop. Now, if current is given, magnetic field is given, I have to find force. So, what will I use? I will use Fleming left hand rule. Correct? So, if I take my left hand, this is the direction of current, direction of magnetic field, and the force is what? Force is inwards. Correct? In here at this point. On the opposite point at here, the direction of current is now reversed. It is in the opposite direction. So, here the direction of force is outwards. Now, magnitude of force is same. So, what will happen? This force gets cancelled out and this will happen for all the points on this particular loop. Correct? So, the force on this whole loop will cancel out and will become 0. Correct? Okay. Next, 28th question says, a charged particle moving in a uniform magnetic field experiences no force when the angle between velocity vector and the field vector. So, we have to see experiences no force. So, force is what? Q V cross B, that is Q V B sin theta, and it says that it's experiencing no force. So, that means force is 0. Now, at what angle the force will be 0? Ma'am, at angle 0 degree. For 0 degree, sine is 0 and we can say hence that our answer is 0 degrees. Okay. Next question says, 29th, if the beams of electrons and protons move parallel to each other in the same direction, we have a beam of electron and a beam of proton that are moving in the same direction. Now we have to see, then they either attract each other, repel each other, no relation, neither attracts nor repel. Now, first tell me one thing. If the electron is going in this way, then current is going in the opposite direction. Correct? But in case of proton, the current will move in the same direction. So, current in these two rays, in these two beams is in opposite direction, and we know when current is in opposite direction, these two wires will repel each other. If current was in same direction, it would have been attract each other, but since the current is in opposite direction, it will repel each other. Both these wires will repel each other. Okay. 30th question says, the angular velocity of a charged particle moving in a region of uniform magnetic field is independent of. We need to see the angular velocity. Now, ma'am, the formula of angular velocity, we'll just write the formula of angular velocity, and from there we'll know on what factors it depends. That is simply QB by M. So it depends on the charge. Okay, it depends on the charge. Okay, Q, and it depends on the, does it depend on the velocity? Question mark. Strength of the magnetic field? Definitely. Mass of the particle? Definitely. So it does not depend on, that means it is independent of velocity of the particle. Correct. The angular velocity is independent of the velocity of the particle. With that, moving on to the 31st question, which says, match the physical quantities of the column 1 with their units in column 2. So these are the quantities, these are the units. Now this is very simple, we'll just go through it. Current sensitivity, we know it's divergence of A inverse, and intensity of magnetic field is rather ampere per meter. Correct. So this is this, and magnetic dipole moment is ampere meter square. So we have one with current sensitivity as C, second as, instead of looking into the options of these, you just use your own brain and solve it. Okay, then you will see the options, because it will be a lot easier for you to find the option that you know is true, instead of looking at the options first and getting confused. Okay, so first is C, first is C in both these cases, second is A, so B option is true, B option is the correct option. Is that easy? When you solve yourself first, it will become easy. Okay. 32nd question says, when the angle between the magnetic moment of a small compass needle and the uniform magnetic field in which it is placed is 180 degree, that means needle is in this direction, magnetic field is in this direction, and their angle is 180 degrees. Then the torque on the needle is maximum, the potential energy of the needle is 0, the needle is in stable equilibrium, or the needle is in unstable equilibrium. What will be the option? I know it will be in equilibrium because it is totally opposite to the direction of magnetic field, but it will not be stable equilibrium, but because it is in opposite direction. It will be, if it was in the same direction, then it would have been stable equilibrium, but in this case it is unstable equilibrium. Correct. 33rd question says, according to Gauss law in magnetism, we have options. Magnetic flux through a closed surface may be non-zero. Magnetic monopoles do not exist. There can be sources or sinks of magnetic field. The magnetic flux through any surface is 0. Now, we know one of the most important significance of Gauss law is that it proves that magnetic monopoles does not exist. So according to Gauss law, magnetic monopoles does not exist is the correct option. Okay. 34th question says, again a matching kind of question. In the following table, column 1 lists magnetic substances. Now we have magnetic substances in column 1. Dia, which slightly repels the magnetic field. Para, which is weakly attracted by the magnetic field. Ferro, which is strongly attracted by the magnetic field. Correct? Now, it has, column 2 has the permeability and then domain formation and then a relation of susceptibility. So, we know since it is repelled, diamagnetic is repelled, so its permeability will be less than the general permeability. Okay. Then paramagnetic is
weakly attracted, but its susceptibility will be more than 1. Ferromagnetic, we know it forms domains, correct? So for A we have what? P, for B we have R, and for C we have Q. A, P, B, R. A, P, these two can be true. B, R. Okay, so B option is true. B is the correct answer. Okay, understood? Okay, 35th question says, a magnetized needle placed in a non-uniform magnetic field. Clearly read it. It's clearly written that it's a non-uniform magnetic field. In general, experiences both force or torque, a force but no torque, a torque but no force, neither force nor a torque. Now, when it is a non-uniform magnetic field, there can be subparts that the needle is placed in the direction of magnetic field, opposite to the direction of magnetic field, then we'll have different answers. But in general, when it's a non-uniform magnetic field, the needle will experience both force and torque. Okay, done. 36th question says, the dimensional formula for magnetic intensity. What? Magnetic intensity is, ma'am, simply we just study magnetic intensity or magnetization was ampere per meter. For ampere, therefore the dimensions are A, and per meter will be L minus 1. So this will be L minus 1 into A. We have our option B, and for 36, the correct answer is B. Okay, 37th question says, if the magnetic susceptibility of a material, is 100, its relative permeability will be what? Ma'am, it's very simple. It's the most easiest formula for magnetism, that is mu R equals to 1 plus xi m, correct? And 1 plus this is given as 100, so that will be 101, and we have our answer as C, correct? Okay, 38th, if the magnetic, okay, it's the same, maybe I did a mistake. Okay, 39th, the atoms in which kind of magnetic materials have permanent magnetic dipole moment? Only diamagnetic, only ferromagnetic, only paramagnetic, both para and ferromagnetic substances. Now, since we know diamagnetic are weakly repelled by magnetic field, so they won't have that much, they definitely won't have permanent magnetic field. That is the case of both para and ferro. Both para and ferro have permanent magnetic dipole moment. Okay? Okay, 40th question says, if a magnetic substance is kept in a magnetic field and is free to move, this is free to move, then which of the following substance moves out of the magnetic field? Okay, the substance that will move out of the magnetic field will be the one which is repelled by the magnetic field. Which one is repelled by the magnetic field? Diamagnetic. So the answer is clearly diamagnetic. 41st question says, we have two statements. Read it very carefully. The first is the net magnetic flux through any closed surface is 0. Statement 2 says the number of magnetic field lines leaving the surface is balanced by the number of lines entering it. So both of these statements we know are true and they do make sense. Number of rays that are entering is equal to the number of lines that are leaving. So that's why the net magnetic flux will be 0. So these both are true. 42nd question says, in electromagnetic induction, the induced EMF in a coil is independent of change in the magnetic flux, time of change of magnetic flux, resistance of the circuit, number of turns in the coil. Now, for this you should remember the formula for electromagnetic induction, which is nothing but minus n d phi by dt. Now, this is definitely change in magnetic flux. Correct? Time of change of magnetic flux is still the same thing. Resistance of the circuit. I can't see anything R or resistance in this formula, right? or number of turns in the coil, which we definitely have. Oh, now this is a question of a chapter EMI, electromagnetic induction. Okay, so the correct option hence we know will be resistance of the circuit. Okay, next is 43rd, inductance of a coil is independent of what? The geometry of the coil, the current through the coil, the medium inside the coil, or number of turns of the coil. In this case, we know it is the inductance of a coil never depends on the current through the coil. Correct? So it is current through the coil. Inductance of a coil is independent. It definitely depends on the geometry, it depends on the medium, and it depends on the number of turns. So the correct option is current through the coil. 44th question says, if the current flowing through a coil is doubled, then the magnetic energy stored by it. Now, if the current flowing through a coil is doubled, the magnetic energy stored by it will be what? Now, for magnetic energy, what is the formula? It is half Li square for a coil. Okay, this is for a coil. So, if current is doubled, this will become what? This will become 4 times. Understood? Very simple. Next, 45th question says, an EMF is induced across the ends of a moving conductor coil in a magnetic field. This is in accordance with, ma'am, this is very simple. This is just directly Faraday's law, and while we are on these laws, you need to remember all the perfect definitions and formulas and their significance of all these laws. Gauss law in electrostatics, in magnetism, Ampere's law, Faraday's law, everything. Okay, they should be on your tips. Okay, 46th question says, the phenomena of induction of an EMF in a coil due to change in current through the same coil is mutual induction, self-induction, motional EMF, induction of magnetic field. Ma'am, if the word written is same coil, it's definitely directly self-induction. Okay, 47th, consider the following 2 statements. Statement 1, when 2 coils are wound on each other, the mutual induction between the coils is maximum. Is it true? Is it not? Statement 2 says, mutual induction does not depend on the orientation of the coils. Now, this can be a little tricky, but we know when 2 coils are wound on each other, the mutual induction is maximum. The statement 1 is definitely true. It is definitely true. About the statement 2, mutual induction definitely depends on the orientation of the coil. We know if they are oriented parallel to each other, the mutual induction is maximum. If they are oriented perpendicular to each other, it is minimum. So, it definitely depends on the orientation of these coils. So, statement 1 is true, but the statement 2 is false. Moving on to 48th, if the current flowing through a coil is doubled, the magnetic energy stored in it. Oh, this is the same question we did. I repeated it, I guess. So, this becomes 4 times. Okay. 49th question, in an AC generator, when the plane of armature is parallel to the magnetic field, then both the magnetic flux and EMF are maximum. Both the magnetic flux and EMF are 0. The magnetic flux is 0 and EMF is maximum. The magnetic flux is maximum and EMF is 0. Now for AC generator, if you remember, phi is nothing but BA cos theta. And the EMF is nothing but d phi by dt. Correct? Negative of d phi by dt. Now that means E will be what? E will be BA sin theta. Correct? And here the plane is parallel to the magnetic field. That means normal to the plane will be perpendicular to the magnetic field. Correct? If the plane is parallel to the magnetic field, then it's normal. This is the plane's normal. The stylus is the plane normal. And this, my finger, is magnetic field. So, the normal and the magnetic field, normal to the plane and magnetic field will be perpendicular to each other if plane and magnetic field are parallel to each other. So, theta is what? 90 degree. That means phi is simply 0 and E will be sin theta is Sin 90 is maximum, so you will be simply BA, which is maximum. See, I solved it without looking at the options, because in these kind of questions options will just confuse you. So you try to solve it by yourself. If you can't, then look at the options. Okay, so magnetic flux is maximum and EMF is 0. Okay, 50th, we are on 50th question from the chapter alternating current. The question says, in a purely capacitive circuit, if the frequency of AC is doubled, the capacitive reactance, what? Capacitive reactance, the formula for capacitive reactance is what? 1 by 2 pi nu, that is frequency, into C. If the frequency of AC is doubled, now nu becomes what? 2 nu. So this whole becomes, nu 1 becomes what? 1 by 1 divided by 2 pi into 2 nu into C, correct? So this whole term becomes half of the original one. You can write XC nu equals to XC divided by 2. As other than this 2, the whole term is this one only, correct? So the capacitive reactance becomes half. It gets halved of the original value. Okay, 51st question says, the use of laminated core in a transformer reduces energy loss due to flux leakage, coil resistance, hysteresis or eddy currents. Now, whenever there is a change in magnetic flux inside a transformer, whenever there is a change in magnetic flux, it produces eddy currents. And eddy currents are the reason why energy loss happens. Now, because of this energy loss, because of these eddy currents, energy loss is happening. Now, if we laminate the core, it will produce resistance to the eddy currents decreases, energy loss will not happen, correct? So the use of laminated core in a transformers reduces energy loss due to eddy currents, correct? Okay, next question says 52, the frequency of AC is increased, the impedance of a series LCR circuit will be what? Again, a good thinking critical conceptual question. Now, the impedance of a series LCR circuit we know is R square plus XL minus XC square. Correct? This is the formula. Now now XL is 2 pi frequency into L, XC is 1 by 2 pi F into C. Now at low frequency, XL minus XC decreases. But as the frequency, because here the frequency of AC is increased. So as the frequency is increasing, this whole term, the XL minus XC term, this one, it increases and hence in turn the total impedance increases. So the correct option is it first decreases and then increases. Correct? Okay. 53rd question says power factor for a purely resistive circuit. Now power factor is nothing but just cos phi, where phi is the phase difference. Now in a purely resistive circuit, I know current and voltage have phase difference as 0 degrees, correct? They are in phase with each other. So P equals to cos what? Cos 0 and P equals to hence 1, which is what? Which is unity, correct? Okay, 54th question says at resonance. Why am I pointing these words with so much effort? Because you need to see the keywords. That's why silly mistakes happen if you don't see these small knickknacks. At resonance, a series LCR AC circuit behaves like a, this is very simple. At resonance, we know XL equals to XC. So it behaves purely as a resistive circuit because Z equals to what? R square plus XL minus XC square. At resonance, these two are equal, so they become 0. This is R square under root Z equals to R, so Z equals to R, and hence it behaves as a purely resistive circuit. Understood the factors behind it, okay, reason behind it. Okay, 55th question says the power factor of a series LCR circuit is maximum. It is maximum at resonance, that is equal to XL when XL is equal to XC. Okay, 56th question, which of the following statement is wrong? Now, AC can be easily and efficiently stepped up or stepped down. That is true. We know this statement is true. B, it is economical to transmit DC over large distances. Is it? But we have studied that in DC over large distances power loss happens. So how this statement can be true? Maybe a question mark. The average value of sinusoidal alternating current or voltage over a complete cycle is 0. So this is my alternating voltage or current over a complete cycle. So the average of the positive and negative parts is 0. So this statement is true. The average power consumed by an AC circuit over a complete cycle may not be 0. But we know the average power cannot be 0. So this statement is of course true. Then which other statement is wrong? The remaining, which we doubted, was definitely, what do you say? It was wrong. We cannot transmit DC over large distances because a huge power loss happens in that. That's why we transmit AC over large distances. Okay, 57th question, the phenomena of resonance exhibited by an AC circuit only if both L and C are present in the circuit, only if both L and R are present in the circuit, only if both R and C are present in the circuit, only R is present in the circuit. So at resonance, again the phenomena of resonance, at resonance XL equals to XC, they should be equal, and resistance gives the sharpness of the resonance, not the existence of resonance. So resonance will happen only if both inductor and capacitor are present in our circuit. Okay. 58th question says the dimensional formula of LC is, L is self-inductance, C is capacitance. Okay, if you forget about this, let's see how you can calculate it. I won't calculate it till the end, but I'll tell you. So U is half Li square for inductor and U is half Q square by C for capacitance. So for C, I can write, just for dimensions, I'm ignoring the half part. For C, you can get Q square divided by U, and for L, you can get, okay, for L, you can get U by I square. Correct? Now write the dimensions of all this. Q equals to IT, that means ampere into time. So square of this divide by, now dimensions of energy we know from first chapter of our first or second chapter of our PU1, that is M1 L2 T minus 2. Correct? Or this is T, capital T. Correct? And for L we have again M1 L2 T minus 2. Correct? And I square is A square. Now we need the dimensions of LC. So you can just multiply these two dimensions and they will cancel each other out and you will get the answer as T square. You can do it and let me know in the comment section if you find any problem doing this. Okay? Okay, 59th question. Displacement current, okay, from EM waves. Displacement current is produced due to constant electric field, constant magnetic field, changing electric field, changing magnetic field. Now ma'am, this is very easy. We know the whole existence of displacement current is due to a very, very important phenomena, that is changing electric field. Correct? So this is very simple. This is changing electric field. Okay. Next, 60th says the expression for displacement current. Now displacement current is a very important topic. You should know about its definition, its cause, why it is happening, its formula. So the basic formula of displacement current is nothing, epsilon naught d phi E by d T. Now you can just match it with the options C. Correct? That's simple. It's just that simple. 61st question says, choose the false statement. Sorry. Electromagnetic waves are produced by accelerated charged particles. Makes sense. For electromagnetic waves, E naught by B naught equals to C, where E naught and B naught are electric and magnetic field amplitudes. Okay. Electromagnetic waves are transverse in nature. Electromagnetic waves can be deflected by electric and magnetic field. Now, ma'am, electromagnetic waves are in itself are a combination of electric field and magnetic field. Why will they be deflected by electric and magnetic fields? Correct? So that is clearly the false statement. And with that, moving on to the 62nd question, which electromagnetic wave is used in long range communication? Now, have you heard your grandmother or grandfather saying that they used to hear cricket matches on a radio? They used to hear commentaries on radios. So that's how you can just remember, if the cricket match is happening in England, they can still hear on the radio what is the commentary happening. So radio waves are used to transfer signal in a long range. Okay, so for long range communication we use radio waves. And for your grandfather, on the name of your grandfathers and grandmothers, all the lovely grandmothers out there, 63rd question. The increasing order of wavelength of infrared, microwave, ultraviolet, gamma rays is what? Okay, these are all the options you can read, but I have a quick trick for you, which is let me remember, it's something like good uncle is angry or gets angry, something like that. Let me just see the exact this whole sentence. Let me just see it. I have it somewhere. I can't find it. This is, yeah, good uncle is mad. Sorry, not angry. Good uncle is mad. So you can remember, this is gamma rays, and this is ultraviolet rays, infrared rays, and then microwaves. That's how you can remember this. But remember this for increasing order of wavelength. So gamma, then ultra, then infrared, then microwaves. Good uncle is mad. Okay, increasing order of their madness, let's say. Okay, so this is gamma rays, ultraviolet rays, infrared rays, microwave rays. 64th question, very easy. Speed of light according to Maxwell's equation is given by, ma'am, this is very simple. Just don't waste our time. This is inverse of the root of mu naught and epsilon naught. 65th question. And we are moving on to the chapter ray optics. The speed of light in a medium depends on angle of incidence, angle of refraction, refractive index, its mass density. Now, if the speed of light is going from one medium to another, its direction changes. But why it changes? Because both the mediums are, either one it's rarer, the other is denser. That means they have different They have different refractive indexes, which is generally a property of the medium itself. Okay. 66th question says, for total internal reflection of light should travel from rarer medium to denser, and the second option is from denser to rarer. Third is light should incident along the normal, or fourth is the angle of incidence should be equal to 90 degree. That is not the same thing. Okay, so for total internal reflection, my incident angle should be greater than critical angle, so that it gets total internally reflected. So if this is rarer, this is denser, this is my critical angle. If it is greater than the critical angle, it will get totally internally reflected. So the light should travel from denser to rarer. That is option B. Correct? 67th question says, Snell's law fails Snell's law fails in which case? When light travels from denser to rarer? No, it does not. It applies when it is oblique incidence. Okay, let's just think. When light travels from rarer to denser, it does apply in that case, or normal incidence. First, even if you don't know the answer to this question, you can just use your brain. Every time we have done the questions of numericals of refraction, the light is always obliquely getting incident on the interference surface, right? It is not getting incident with a normal incidence angle. It does not, right? So it gets incident obliquely. So this is also true, and in those cases Snell's law was applicable. So it is true for this case, but in normal incidence, when the incident light is coming parallel to the normal to the surface, then Snell's law will fail. Okay, moving on to the 68th question. The principle of optical fibers is what? Reflection of light, refraction of light, dispersion of light, or total internal reflection. Now we know it's very simple. Optical fibers, it's based on the principle of total internal reflection. Correct? 69th question says the focal length of a lens depends on first, refractive index of the material, radii of the curvature of two surfaces, diameter of the aperture. Now, again, for this you need to know the formula. So, the formula for focal length is n minus 1, 1 by r1, 1 by r1 minus 1 by r2. So, it is definitely depending on the radius of refractive index of the material, that is this one. It is definitely depending on the radii of curvature, that is this one. But we cannot see any term related to diameter of aperture. So, the correct option, that it does not the correct option, it does not depend on diameter of the aperture. So, the correct option is it depends on 1 and 2. Only option 1 and 2, that is our B option. Correct? Okay. 70th question. Two thin lenses of focal length f1 and f2 are in contact. The power of the combination is. Now, even if you don't want to solve it, but of course you have to solve it, but remember they have asked power. For power, we know we just simply add for the combination of two lenses. Now this is 1 by f1 plus 1 by f2, correct? So this will be just simply f1 f2, f2 plus f1. Now this is power, correct? If they would have asked focal length, then this will be 1 by f, and you will have to invert this whole term to find f, correct? Since here they have asked power, so this is simply the answer, which is B option. Correct? Okay. 71st, the angle of minimum deviation of a prism depends on what? Only angle of the prism, only refractive index of the prism, angle of incidence, or both the angle of prism and its refractive index. So, do you know the formula of this? Again, you have to know the formula for this, right? So, refractive index for a prism we know is sine A plus delta m, which is angle of deviation, divided by 2, divided by sine, this is angle of prism A by 2, correct? So, this delta m is dependent on angle of prism as well as on refractive index of the prism. Now, for a particular prism, for a single prism, refractive index and their angle of prism is similar, is constant, correct? It does not change, but angle of deviation does depend on these two, correct? So, the correct option is option D. Okay, 72nd. The magnification of a refracting telescope is what? Ma'am, very simple. It's simply focal length of the objective, focal length of the eyepiece. This is objective by eyepiece. Okay. So, the correct option is A, FO divided by FE. 73rd question, and we are on the chapter wave optics. We have done 73 questions. I don't think we have taken much time. Okay. So, two light sources are said to be coherent when both the sources of light emit light of same amplitude and phase same intensity and wavelength, same speed, same wavelength and constant phase difference. Now, we know for interference, coherent sources are very important, and for coherent sources, phase difference is very important. So, these two options will cancel out because they don't have any phase. Now, the point is to see if these two options, which of these will true. Both will have phase, but this is saying same phase. This is saying same phase, and this is saying constant phase difference. There is a big difference in both these statements. A light can have same phase, but it cannot have constant phase difference. A light should have, like, let's say its phase difference is 30 degrees. So it should be 30 degrees at now. It should be 30 degrees after 30 seconds, after 30 minutes, after 1 minute, and after 30 kilometers, after not 30 kilometers, after 30 centimeters, 30 millimeters, whatever we use to do our experiments, correct? So the exact point is it should have constant phase difference. So the correct option will be D. Understood? It should have constant phase difference. Okay? Okay. 74th, what would be the resultant intensity at a point of destructive interference if there are two identical coherent waves of intensity I naught producing an interference pattern? Again, we are at the point of intensity. For destructive, we know we can simply minus or subtract two intensities of those two waves. So this is I naught and this another is also I naught. So this will be simply be 0. The net intensity of both these two waves, if they are forming a destructive interference, destructive pattern, will simply be 0. Correct? Okay. So the option will be C. 75th question. A beam of unpolarized light of intensity I naught is passed through a pair of polaroids. Remember, it's a pair of polaroids, not just a single polaroid. With their pass axis inclined at an angle of theta, the intensity of the emergent light is equal to what? So, we have a light whose intensity is I naught, correct? This is my first polarizer. Since it's a pair of polarizer, the another polarizer is inclined at an angle of theta. So another polarizer is something like this. Correct? This is pass axis. Correct? Now we know when it passes through first polarizer, and remember this very carefully, the intensity becomes a half. Correct? Now when it passes through the second polarizer, this is my polarizer. When it passes through the second polarizer, this will become I naught by 2 cos square theta. Correct? So the correct option is D, that is I naught by 2 cos square theta. Understood? 76th question says, when a point source of light is placed at the principal focus of a thin convex lens. We have a thin convex lens and a point source is placed at its focus. Correct? The shape of the emergent wave front. They are asking the shape of, oh, just give me a second. The shape of emergent wave front. That will be, for focus, the rays will go something like this and they'll become parallel to principal axis. Correct? So the wavefront will simply be plane wavefront. Correct? So for 76, the correct option is plane wavefront. 77. The shape of the wavefront for light coming from a distant star is spherically convergent wavefront, spherical divergent wavefront, plane wavefront, cylindrical wavefront. Now again very easy. This is a star, it's very far away from us. Even if it's giving, even if we take it as a point source and assume that it's giving spherical wavefronts, but until it reaches us, the wavefront will become almost plane and we will see a plane wavefront. Okay, so the correct option is plane wavefront. Correct? 78th, we will have constructive interference if the path difference is n equals to 0, 1, 2, 3, 4. So we definitely know this is the most basics of wave optics. For constructive interference, the path difference should be integral multiple of the wavelength, and in all these cases nothing is the integral multiple. This is the only integral multiple of wavelength, so A is the correct answer. Even if n plus 1 you say is the integral multiple, but this is lambda by 2, right? Correct? Okay. 79 question says, two lights each of intensity I0 are used in Young's double slit experiment. The intensity of the interference maxima. Now we need to tell the intensity of interference maximum. Again we'll see formula. I net is according to the original formula. This is I1 plus I2 plus root I1 I2 cos phi, and this is 2. Correct? So the option, now they both have intensity I0. So we'll just add it. I0 plus 2 under root I0 into I0 square. For interference maxima, the phase difference will be n lambda, or we'll take as 0. So cos 0 is simply 1. So this will be 4I0. Clearly understood? So the answer is C, that is 4I0. Okay, moving on to the dual nature of radiation and matter. A very good chapter, I'll say. The de Broglie wavelength of a moving particle is independent of the dash of the particle. What? It is independent of charge, mass, speed or momentum. Now we know lambda is nothing but h by mv. Correct? So this definitely has mass, this definitely has speed, and the overall quantity is simply momentum. So lambda does not depend on charge, that is, it is independent of charge, and hence the correct option is A, charge. 81st, emission of electrons from a metal surface by heating. So how you can remember is called photoelectric emission, thermionic emission, field emission, secondary emission. Heating is thermal. From thermal, we can say it is thermoionic emission. Okay, so it was thermoionic emission. 82nd, in photoelectric effect experiment, if only the frequency of incident radiation is increased, what will happen? The maximum kinetic energy of the photoelectron decreases, the stopping potential increases, the photoelectric current increases, the photoelectric current decreases. Now ma'am, we know that photoelectric current or the current never depends on frequency, it depends on intensity of the incident light. So these two options are clearly wrong. Okay, these two options are clearly wrong. Now among these two options, they are saying when the frequency is increased, the maximum kinetic energy should also increase, but they are saying it decreases. So it is also wrong. So the correct option will be the stopping potential increases. So B is the correct option. Okay. 83rd, the sufficient energy by the electron to overcome the attractive pull of metal surface is called. Now I have a metal surface, correct? We have electrons here, correct? And photon, a light ray is coming. Now when light ray is incident on the metal surface, the electron gets ejected, but there is a condition. Electron gets ejected only if the energy of this light is more than the work function of the electron, which is the attractive pull of metal surface and the electron. So work function is the correct answer. Okay, 84th. In a photon particle collision, which of the following is conserved? Only total energy, only momentum, both momentum and total energy, neither total energy and momentum. Now among these options, two are definitely wrong. Only momentum or neither momentum. Why? Because energy is always conserved. Energy is conserved in all cases. So only momentum is conserved is definitely wrong. Neither energy nor momentum is definitely wrong. So out of these two, only total energy is conserved, but in case of photon particle collision, we know that momentum is also conserved. So the correct option is then C. Correct. Now 85th says the gathering and focusing mechanism of light by the eye lens. This you should remember. You can remember the gathering and focusing mechanism of our eye lens is due to the wave nature, is described by the wave nature of light. On the other hand, the rods and cones on our retina, their function is described by the particle nature of light rather than wave nature of light. Okay. Next chapter, atoms. From kinetic theory, the size of an atom was known to be 10 to the power minus 10, 10 to the power minus 14, 10 to the power minus 22, 10 to the power minus 18. Now, this you should remember. There is no logic in this. It's clearly 10 to the power minus 10. Of course, we remember this quantity very well. This is the size of nucleus. So, my size of atom will be definitely bigger than the size of nucleus, right? So, even if they ask about anything else, electron, proton, atom, molecule, you just remember this and then make an idea from there. Now definitely 10 raised to the power minus 18 is even smaller. So atom can't be smaller than nucleus. It will definitely be bigger. So 10 to the power minus 10 is the correct answer. Okay. Okay. 87th question says the condensed matter and dense gases at all temperature emit electromagnetic radiation due to high temperature, oscillations of atoms and molecules, head-on collision between atoms and molecules, none of these. Now, clearly in condensed matter and especially in gases, we know the particles are oscillating, correct? So, the electromagnetic radiation that emit at all temperature is due to oscillation of atoms and molecules, correct? 88th question says, according to classical theory. Again, why am I forcing so much on classical theory is because there are other theories. So your mind shouldn't be confused which theory we are seeing. According to classical theory, the electron will fall into the nucleus. That is correct. Statement 2 is an accelerated electron emits radiation in circular path. Both statements are clearly correct. We have studied that in classical theory, electron is revolving around the nucleus, but its radius is getting smaller as it's emitting energy, and hence it falls into the nucleus. So both these statements are correct, and the second is the correct explanation of 1. 89th question says, the minimum energy required to free the electron from the ground state. So hydrogen atom, this is its ground state and we have electron in this. We have to free this electron. We don't have to excite this. We don't have to de-excite this. We have to free this electron. So for taking it out of the hydrogen atom, we know that is ionization energy. 90th question, the alpha particles are nuclei of. They didn't ask what alpha particles are. They asked alpha particles are the nuclei of. Clearly not hydrogen atom. They are the nuclei of helium atom. Now helium 2 positive atom is in itself a alpha particle. But they did not ask what alpha particle is. They asked the alpha particles are nuclei of. That is helium atom. Correct. 91st question says, the negative sign in electrostatic potential energy of an electron signifies that potential energy of an electron is unstable. Electrostatic force is in the minus r direction. Kinetic energy of all electrons is constant, or none of these. Now, again, very simple. Electrostatic potential energy of an electron is definitely because the electrostatic forces are in negative r direction. So the answer will be option B. Correct. 92nd, and we are moving to the chapter nuclei. 92nd is isotones are atoms having same number of protons but different number of neutrons, same number of neutrons but different number of protons, same mass number, or none of the above. Now isotones, from tones I have remembered that is neutrons. Of course you can say electrons, protons are same, but it just vibes. Isotones and neutrons feels like cousins or brothers. So it has same neutrons but different number of protons. Okay. 93rd question, the radius of a nucleus of a mass number A is directly proportional to, we directly simply know that it is directly proportional to A to the power 1 by 3. So R is directly proportional to A to the power 1 by 3. That is our option D. Correct? 94th says binding energy of a nucleus is. Now you should definitely know the definition of binding energy, which is the energy it is required to break the nucleus into its constituent particles, or we call it nucleons. So option A is energy given to its nucleus. That is definitely not true. Total mass of nucleus converted into energy units. That is also not true. Energy required to break a nucleus into its constituent nucleons. That is true actually. And the total energy and potential energy of the nucleus in the nucleus. That does not make any sense. That is also false. The correct option is option C. Correct? We are at 95th question. The binding energy per nucleon is maximum. Now we know the curve of binding energy per nucleon. This goes something like this, and at this maximum we have iron, and so the binding energy per nucleon is maximum in case of iron. Okay. 96th question says radioactive substances emits alpha rays, beta rays, gamma rays, all of the above. Now we have studied, ma'am, we have studied alpha decay, beta decay, gamma decay. So we know that radioactive substances radiate all these rays, so they emit all these rays. So the option is D, that is all of the above. 97th, and we are moving on to the chapter semiconductors. Not very big chapter, but I really like this chapter. The valency of an impurity added to silicon crystal. What? Silicon crystal, and we have added an impurity to convert into an N-type semiconductor. Now we can convert silicon into either P-type or N-type. While converting it into N-type, what we need? We need an extra N-type N particle, that is negative particle, that in basic sense should have one more electron. So silicon is what? Silicon is tetrahedron. That means its valency is 4. So the impurity we are adding should have one extra electron. That is that the valency of impurity should be one more, that is 5. Correct? 98th question. The majority charge carriers in a p-type semiconductor are not protons, these are holes. The positive, they are positive charge carriers, those are holes. Correct? 99th. A semiconductor doped with a donor impurity. We have a semiconductor and we doped it with donor impurity. A semiconductor doped with a donor impurity is what? It will be N-type semiconductor. N-types are donor impurities, and hence a semiconductor doped with a donor impurity will become N-type semiconductor because it will have an extra electron. Okay? 100th question. A cut-in voltage for silicon diode is approximately what? We have crammed it in our hearts and our brain that the cut-in voltage for silicon is what? It's 0.7 volt. I think if someone will wake you up in your sleep and ask you what is the cut-in voltage for silicon, you will tell it's 0.7 volt. Okay, but I have got you 2 bonus questions. Maybe they can come in both, so don't skip. 101 question. Oof. A PN junction diode is used as an amplifier, a rectifier, an oscillator, a modulator. You will comment down the answer to this in the comment section. Okay, let me give the answer for this and I'll give you one more question so that you can answer in the comment section. For this, a PN junction diode is used as a rectifier. We have studied rectifiers. We have studied their working, construction, everything. And we use PN junctions to create rectifiers. So, PN junction diode is used as a rectifier. 102 question. In a semiconductor, the concentration of electrons is 8 into 10 raised to power 14 per centimeter cube, and that of holes is 5 into 10 raised to power 12 per centimeter cube. We are given with the concentration of electrons with the holes. The semiconductor is p-type, n-type, intrinsic, p and p-type. Now this is the question you have to answer in the comment section right now. I will see and I will definitely check who is answering. So this is all the questions we have done. 102 questions from the question bank, 1 marker questions. If you do this, I can guarantee you will get a lot of marks in your exam from your 1 marker. Also 2, 3, 4, 5 markers will be covered by Soumik sir. So don't take any tension, relax back, follow the Diksha Karnataka channel and you will be all good. Okay, so I'll meet you in the next video. Till then, tada bye bye. Keep studying.